Happy morning to remember. I'm J. Sobalakshan from National Engineering College from the domain of Electronic and Communication. For this internship, I have taken a topic on microwave oven stimulation. And my internship overview is goals of internship, projects requirement, design, embedded systems, design of embedded system, project implementation, and conclusion. First, goals of internship. Goals of internship: to learn the basic concepts of embedded system and the hardware and software requirements needed to build embedded system. Able to build an embedded system on our own using hardware and software. These are the goals that we have learned from internship, to build both hardware and software in an embedded system. And the next is project requirement. Project requirement. Basics of embedded C. To build an intent product, we need to know the basics of embedded C and basic C programming like data types, arrays, and pointers, and MPLAB X IDE, a stimulator, and XC8 compiler to compile a program, and PIC SimLab. In that PIC SimLab, PIC 16F877A, tactile switch, 16x8 characteristic LCD display. This liquid crystal display to display an output, timer, and interrupts. These are the project requirements. We need to build an microwave oven stimulation. And first, embedded system. We all know that embedded system is a combination of both hardware and software, where the software is embedded into an hardware. It is called as an embedded system. This is a very basic definition, and it is an electronic system that can be programmed based on our needs. There are a set of protocols where we can organize the way of working and controlling the system. The hardware where the system is embedded is built with the help of microcontroller. The hardware where the software is embedded in the build is built with the help of a microcontroller. The hardware is comprised of a user interface, which includes the display of input and output interfaces, and memory of a system, which we consider the types of embedded systems like power supply, processor, and communication ports are needed for the system to function properly. Based on the performance and functions requirement, embedded systems are classified as standalone embedded system, networks embedded system, and mobile embedded system. These are the three types of embedded system. The next we have is design. In the design, the second one is parameters to choose embedded system. First, we have chosen a project in embedded system. Why the embedded system? Because embedded system is reliability, and it is cost free, and it consumes more and less power. That is, power consumption is less, and performance, we can get greater performance and speed and memory. Here, factors that is selected for embedded system. Here, speed and performance is very good, optimal power usage, cost and advanced processing, and peripheral support, which is in architecture. The peripheral supports are very. Then next, to design an embedded system, C programming language is very important. In that C programming, data types, arrays, and pointers are included. First, data types. Data types are very basic in C language. That is, each variable in C language is associated in a data type. It is a specific the type of data that the variable can store, like integers, any integer values, characteristics like A to Z, and floating, double, there is a point values, etc. Each data requires a different amounts of memory, because to store a variable or data or characteristics will be required a temporary memory, like a memory in a C program. Array. Arrays are used to store a multiple values in a single variable. A group of characters or words are stored in a single variable, instead of declaring a separate variables for each values. For example, embedded system. If A is equal to embedded system, then we can declare only A, because the A itself initializes that A is equal to embedded system. For example, to create an array, define the data type and specify the name of the array followed with a set of square brackets. Every array should be specified with a set of square brackets. Now pointers. Pointers are one of the core components of C languages. A pointer can be used to store a memory address of other variables. It is used to store a memory address, the address of some memory, that is some values of data or characteristics. It can store that address of that memory, functions, even some other pointers also. Next we have completed about C programming. Now microprocessor and microcontroller. First, processor. Microprocessor are extensively in a design of any computing facilities. It contains using to carry out arithmetic and logic calculation, fast storing in terms of registers and associated control logic to set instructions from memory and execute them. A number of devices can execute them. A number of devices can be interfaced with them to develop a complete system of application. Here there is two types, that is microprocessor, microcontroller. Processor, it only consists of internal central processing unit. Within that it contains a memory, but in controller there will be external memory present. Next, functions of microprocessor. It processes the general task only, but in controller it processes both process and control the specific task. Memory. In processor there will be no built-in memory, but in controller there will be RAM or ROM like memories. Processor is used in general purpose computer like PCs, modems and printers. Controllers are used in AC, washing machines and home automations. Processors are more complex and large number of instructions are used in architecture. Controllers are very easy to design. It is less complex and less number of instructions only used to construct. For developing a processor embedded system, it is more costly and design time will be very more. But in microcontroller, it is very less and design time will be very less. Efficiency for processor is very less and efficiency for a controller is very more. And architecture, it is a very important, where processor comes under the architecture von Neumann, that is program and data stored in the same memory. But controller comes under a hardware architecture, where programs and data are stored in a different memory. The processor or has built in some memory. Example of processor is 8085 and 8086, and for microcontroller is 8051. That is processor controller internal central processing unit. Controller has some memories or IO chips. On the other hand, controllers are single computer chips integrating a processor, memory, and other peripheral modules into a single system on chip board. Apart from input and output port, the peripherals often include timers, data converters, communication modules. The single chip solutions make the footprint of an communicational element small in that overall system package, eliminating the necessity of an additional chips and boards. However, there exists a large range of such products, while the similar microcontrollers are very cheap and their capabilities in terms of program size and analog and digital peripherals are also limited. Such processor may be suitable for small applications. Next, MATLAB X IDE and PIC Simulation Lab. MPLAB X IDE is a software that runs in a computer intended to develop an application for microchips and microcontroller and digital signal controllers. It is some application of software to compile any programs in embedded system. And it is an integrated development environment, that is IDE is defined as. It is a powerful tool to enable a designer to discover, configure, and develop and debug and qualify embedded designs for most microchips or microcontrollers and also for some digital signals. This MATLAB IDE is especially used for only C languages. The C language program is used. And MP Lab is based on an open source cross-platform NetBeans platforms. That is, it's open to all. It is very easy and functional. It is, and this MATLAB MP Lab X IDE is available for download, free download only for microchips websites. This peripheral interface controller Stimulation Lab, although general instructions originally it is stands for Programmable Interface Controller. A real-time stimulator. It is a real-time stimulator development boards with integrated for debugging, supports some PIXMs microcontrollers and also some SPIM AVR microcontrollers. It is an Arduino IDE for programming the boards of microcontrollers. Next, peripheral interface controller 16F8778. It is one of the most renowned microcontroller in an industry. The microcontroller is very convenient to use. The coding or the programming of a controller is also very easier in peripheral interface control 16F8778. One of the main advantage that it can be write and erase as many times as possible because it uses a flash memory technology. If we have done any mistakes, we can erase it easily and we can rewrite it. It has a total number of 40 pins and there are 33 pins for input and output. This has total 40 pins and 33 pins for input and output connections. Next, tactile switch. It is one type of switch which is widely used, a switch that completes an electrical circuit typically when pressure is applied to device by the user, which is then given as a user perceptible click or haptic pump to respond, indicating the current flow. When pressure is given, the current flow should be indicated by using a tactile switch, by applying like a switches on and off condition by giving a click. CLCD, character liquid crystal display. Of course, it is a liquid crystal LCD display to display an output. In peripheral interface controller, sim app simulator, there are two types of displays: 16 cross to display, 16 cross 4 display, which is used for projects. 16 cross 4 is used for projects. There are two kinds of communication models. Communication models for 8-bit mode and for 4-bit mode. And 8-bit mode for use for a project, and 16 cross 4 display is used for doing in projects. The 16 cross 2 LCD display is basic module commonly used for dice and circuits. It is very commonly used. Now, timers and interrupts. The peripheral interface controllers microcontroller chips has three different timer modules: timer 0, timer 1 and timer 2. The peripheral interface controller consists of both hardware and software interrupts. If the interrupts gets generated by external hardware at certain pins of microcontroller or by inbuilt device like timer, they are called as hardware interrupts. The interrupts which are generated by external hardware are called as hardware interrupts, while software interrupts are generated by a piece of code in the program. The software are generated by writing a program, also known as external and internal interrupts. Now, about our project design. Microwave oven. Microwave ovens are a machine that are used to heat a food using an electromagnetic waves called microwaves. These machines work four different modes, namely micro mode used for traditional cooking, uses maximum power 900 watt. Grill mode Use it to cook meats like chicken or any use good set timer. Time according to meat is used. We can keep and we can do any other works. Convection mode, it uses 3 minutes to preheat the oven to use at a defined temperature, because if we're baking a cake we need a heated microwave, so it should be preheated for that. Next, start mode, it uses to default timing of 30 seconds. It is a start mode. These are the four different modes of microwave machines. Now we can see the stimulation video. Here, this is a stimulation video. Here the program are given for a stimulation. Here now we can adjust the needs. First, cooking mode, and there are given a many subdivision modes. We have used a C language here. By using if else and case state, I have written a program, and if it is get success like that, I have given. And to display for a clock period, I have given a many things. For clock period I have given for just 200, and for second clock period, for to time initialize a timer, I have given an timing up to 250. And for timer and interrupt, I have given right a separate program. And to stimulate, and I have to stimulate, I have used an peripheral interface controller stimulation. And like here, micro grill convection and start mode, you can see here. And if we on it, then powering on, the microwave oven will be start. I will show here. There I have given up to 20. If I change that, to select and microwave, see here it's open, powering on. And for this I need to click and timer value. After clicking a 30 seconds of a timer value, if I press and enter, that is a clear button from here, and the fan will start rotating. The fan will start rotating. Start for 4th pin and pass for 5th pin and 6 stop pins. And again, if we need to get any other mode like convection mode, then you can change by setting the values, and again the timer will be going. And after entering the timer value, if we press enter button, and the fan will start rotating again. For preheating, I have given a timer value as 170. And in this video I have run this program for two. I have took this video from my Stimulation and I have combined this video. For this, in this video I have taken a video for only micro mode and grill mode, that is for 250 and 230. And conclusion. Thus, we made a microwave oven stimulation using an MPLab X IDE, a peripheral interface controller, Stimulation Lab, and X8 compiler. For four different, I have shown you two types and the basic concepts of an embedded system and C programming. And I have completed all my overviews like project in goals of internship, project requirement, design and embedded system and design for embedded system, project implementation and conclusions. Thank you.